Let us now look at a few examples on how images are formed by curved mirrors. Number 1, concave mirror. Locate the images of objects at the following positions, hence state their characteristics. An object beyond C and an object between F and P. C is the center of curvature, F is the principal focus, and P is the pole. Solution. So, we already have the diagrams of the rays of the mirrors. So we need to locate the image of the object O that is positioned beyond C in a concave mirror. In order to do this, we need at least a pair of the rays that we had discussed earlier. So number 1, we will take a ray that is parallel to the principal axis and passes through the tip of the object. Such a ray will be reflected to pass through F after reflection. So that is the ray parallel to the principal axis. So this ray is reflected to pass through F. Remember, we must always indicate the direction of rays using arrows. Because we need at least 2 rays, we will also use a ray that is passing through C. A ray through C is reflected in such a way that it follows the same path after reflection. So that if the mirror is extended, then they would meet at a certain point. So this is also a ray through C, which is reflected to pass through the same path after reflection. So in this case, the image of the object would be between C and F. so that the image is at this point. The characteristics of the image formed are as follows. From the diagram, we see that the image is formed between C and F. The image is formed between C and F. The image is real. That is why it is formed from real rays. The image is upside down or inverted, and the image is smaller than the object. Let us now locate the position of the image for a concave mirror when the object is between P and F. So we again need a ray that is parallel and close to the principal axis, and such a ray will be reflected to pass through F. So the ray passes through the tip and it is reflected to pass through F. After reflection. On the other hand, a ray that passes through C is reflected to pass through the same path after reflection. So to find the point where the two rays intersects, we need to extrapolate the rays. So this is the ray that is reflected to pass through C. We need to extrapolate the rays in order to find the point where the two rays intersect. So we extrapolate the reflected rays. So in this case, the image formed is virtual and the rays leading to its formation are also imaginary rays. Also imaginary rays. So the characteristics of the images formed when the object is between P and F are as follows. The image is behind the mirror. The image is virtual. And all these characteristics can be observed. It is upright or erect. And the image is also enlarged. It is bigger than the object. The image is bigger than the object. Here we note that concave mirrors will always form real images unless the object is between P and F. So concave mirrors only form virtual images when the object is between F and P. So it is important to note that concave mirrors only form virtual images when the object is between F and P.